we are to describe the motion of a particle in one dimension. The first thing is to fix a frame of reference. In this case, we have a vertical axis y, and in the initial time, our particle will be here, and our particle will have a height y sub 0 and an initial velocity v sub 0. From this point, our particle is going to reach this level. This level has a height y max, and from this level our particle is going to fall down until it strikes the floor or other obstacle. We are interested in two things. The first one is the maximum height, and the second one is the time of flight. Remember, here the gravitational acceleration has this direction. Okay, we are going to use the kinematic equations for position and velocity. For the position, we have this equation. And for the velocity, we have this equation. Okay. To find the maximum height, we need to remember that in this level, the vertical velocity is 0. So, if in the equation 2, we make 0 equals v0 plus g times t, we find that t equals minus v sub 0 divided by g. This expression can be used in the first equation, and we will obtain the maximum height of the particle. This will be the first expression we are going to use in our program. Okay, now for the time of flight, first you need to understand this time is the time that you record from this position to this position. So if the particle is moving from this point A to this point C, and then from this point C to this point D, this will be the time of flight. So in the first equation, we're going to make y equals 0. So we'll have 0 equals the initial position plus initial velocity times t plus 0.5 gt squared. And this is a quadratic equation. If you solve this equation, you will find that t equals minus v sub 0 plus minus the square root of this minus this. You can make calculations. If you have any doubt, you can comment in the box below this video. This will be the second equation we are going to use in our program. Let's going to start a new program. First, we're going to open the Windows terminal, and in this case I am going to use the desktop space, so I'm going to change my directory. Okay, this is better. And we're going to start a new file. For that, you can put here copy con and the name of the new file. For example, motion 1D point py for Python. And here we are going to press enter and then Control C. This is a trick you can use to create in a really simple way a new file. Now, you can use a Notepad editor or Notepad++ or other editor. This will be a simple program, so we're going to use a Notepad and we're going to open this file. Okay, so the first thing I want to do is to indicate to the user what kind of program is this. So I'm going to write like a title, vertical motion of a particle in 1D. And we are going to separate this title with this slide this way. Okay, remember that the initial position and the initial velocity are things fixed in our program, so you have to ask to the user what velocity and what position at the beginning to use. So we are going to use a function called input. Input allows you to enter information using the keyboard. So, for example, you can put here y0 equals input, and first you can put print enter the initial height of the particle in meters. So we are going to save this program. You can use Ctrl+S or click in this tab, and in the terminal you can type Python and the name of the program you want to run. See, vertical motion of a particle in 1D. Enter the initial height of the particle. So I can put 5, for example. Yeah. You can simplify this here if you use one of the options of the input function. You can put inside the function this message in this way. So you have here directly integrated in this function the question. Again, if we run the program, it's the same as before, but see, in this case the number you enter is outside at the side of the message, not below. Okay, but there is a problem. This variable here will be considered it like a string, so we have to use a casting. It means we have to indicate to Python what kind of variable is this input. So we're going to add this word at the beginning, float. We are indicated to Python that this input is a variable of the type float, a number. This will be the same for the velocity, the initial velocity. So v0 equals float input, enter the initial velocity of the particle in meters per second. And only for testing this, we can print where is y0 plus v0, for example. Save the program and run it. For example, the initial height can be 1 and the initial velocity can be 2, so if you add 1 and 2, you obtain 3. See, 3.0, because here we are indicated that it's a float variable, nor an integer. Okay. Okay. So remember the two equations: the equation for the maximum height and the equation for the time of flight we found in the last part of the video. So we are going to use those equations. Type those equations here. So we have ymax equals y0 minus v0 times v0 divided by g plus 0.5 times g times v0 divided by g squared. You can write this and write that in this way. Okay. And for the time of flight, we have Tf equals the solution of our quadratic equation. Okay, how we can extract a square root from a number? Okay, for do that, we are going to include a library that is called math. So at the beginning of our program, we are going to write import math. In this library, there is a function called square. So we're going to type math dot square and the number we need to take the square. In this case, b0 plus b0 minus 2 times y0 times g. Okay, see, we are using here the minus sign and not the plus sign because this is a simplified version of the problem, and if you use the plus sign, there are some possibilities that the time flight will be negative. And you know, we are considering the time as a positive or zero quantity. Okay, so we can add here two prints the results of our program. The first one will be the maximum height reached for a particle was, and the flight time of the particle was, and later of the first print we need to include the first result. The same applies for the second print. How we can include a number inside a print? Okay, first you need to locate the place you want to use for that number, and then you are going to use keys. In this case, there is a good location, and this is the other location. And inside the keys, you are going to write the number. In this case, the variable Gmax, and in the second case, the variable TF, time of flight. And you are going to indicate to this function that this is a float variable, and for that you are going to use the F letter at the beginning of the sentence. Okay, so the max height reached for the particle was Gmax in meters, so we can add a M here, and for the time of flight S for seconds here. We're going to save our program and running. So enter the initial height of the particle in meters, for example 5 meters, and the initial velocity, it can be 10. Okay, see, here we have an error. G is not defined. Of course, we have to indicate to the program that G is minus 9.81. This is our gravitational acceleration. Save again, run again with 5 and 10. And we have here the max height 10.09 meters and the flight time 1.227 seconds. Okay, this can be time of flight. Okay. You can round this number using the function round. So you can put here inside the keys round parentheses y max, and you can indicate to this function round that you only want to keep two numbers from the decimal point, for example, in this case 0 and 9. So you can put here 2. The same for the time of flight. Okay. If we repeat the running of the program, you can see now in the first case 0, 9, it's approximated to 1, 0, so we have here only 1, and in the other case 22, like here there is a 7, it's converted to 23. Okay, really good. That will be the first application for this program, how to find the max height and the time of flight of our particle in one dimension.